Okay, here we go. Solving inequalities and absolute values. So the thing you have to remember about inequalities, how is solving an inequality different? Well, if you start with the concept 5 less than 6, you can add 2 to both sides. You get 7 less than 8. Still true. You can multiply both sides by 2. 10 is less than 12. Still true. Subtract 2 from both sides. 3 is less than 4. Still true. When you multiply by negative 2, you get negative 10 less than negative 12. False. So here's the deal. When you multiply or divide both sides of an inequality by a negative number, you're inserting the negative. To keep it true, you have to flip the inequality. So now it's true. Alright, so if I'm solving this inequality, we start simply by subtracting 3 from both sides. So negative 2x is greater than 8. Divide by negative 2, I get x. I must flip the inequality, which is negative 4. Now, so that means I can pick any number less than negative 4. So when we do an inequality, we draw a number line. So here's 0, here's negative 4. X less than negative 4 is an open circle because there's no equality. So I can pick any number less than negative 4. Example, I could pick x equals negative 5. So if I plug in negative 5, I should get a true statement. Negative 2 times negative 5 is 10. 10 plus 3, we want that to be bigger than 11. 10 plus 3 is 13, which is greater than 11. True. Now I could pick 4. Negative 2 times negative 4 plus 3 is greater than 11. So that would be 8 plus 3 is greater than 11. 11 is greater than 11. False. So that's why you can't have a solid dot of negative 4. Okay. So we're going to solve. So you're just going to solve this. So we subtract 23 from both sides. 12x is less than or equal to negative 15 divided by 12. X is less than or equal to, let's simplify that to negative 5 fourths. Now, I subtracted 23 from both sides. I do not flip the inequality. I divide by 12, and I get a negative number on the right. I do not flip the inequality because the number that I divided by, that I put into the problem, is not negative. So now, when I graph this, here's 0. You have to know the magnitude of negative 5 fourths. You have to know that negative 5 fourths is between negative 1 and negative 2. So that's the only time you really need to know mixed numbers. Now, this says x is less than or equal to, so it's a solid dot because of equality and everything to the left. So that means I could pick negative 2 and plug it in, and it should be true. So that's negative 24 plus 23 is less than or equal to 8. So negative 24 plus 23 is negative 1 is less than or equal to 8. True. But see, you can't pick negative 1. So 12 times negative 1 plus 23 is less than or equal to 8. So that would be negative 12 plus 23 is less than or equal to 8. That would be 11 less than or equal to 8. That is false. So that shows you that what you did is right. Okay. Absolute value. What is the absolute value of 3? 3. What's the absolute value of negative 3? It's also 3. So when you do absolute value is actually asking you what is the distance the number is from the origin. Right? That's why they're both positive. Now there's a mathematical definition. So why? Because it's distance. There's actually a mathematical formula for it that says this. That says the absolute value of x is the opposite of x. So when you did negative 3, you actually took the opposite of negative 3 to get 3. It's equal to negative x if x is less than 0. This stands for negative numbers. It's another way of saying it. It's also a part of the domain. The absolute value of x is equal to itself if x is greater than or equal to 0, which is positive numbers and 0. So when I said x is 3, that means I go to this case because 3 is greater than 0. So when I take the absolute value of 3, it's just equal to itself. But when I did x equals negative 3, I'm using this part of it. And so that says when you want the absolute value of negative 3, you're actually taking the opposite of negative 3, and you get 3. So this is the mathematical definition for absolute value. So the thing about absolute values that you have to remember in the back of your head is there are always two cases. So when I go to solve this problem, the absolute value of 2x minus 1 equals 5, I actually have two cases to look at. I have the positive case, notice I'm just bending the bars, and I have the negative case. So here there's nothing to do with the parentheses, you just drop them, add 1 to both sides, 2x equals 6, divide by 2, x equals 3. Here you distribute the negative if you want. Subtract 1 from both sides, negative 2x is equal to 4, divide by negative 2, x equals negative 2. So there are two answers. So my answers are negative 2 and 3. Notice I write them like the smallest one first. So if I take the original equation and I plug in negative 2, I should get a true statement. So here we go. So let's do some arithmetic. 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. The absolute value of negative 5 is 5. It works. So now let's plug, so this was for x equals negative 2. So now let's plug in x equals 3. So that would be 2 times 3 minus 1 is supposed to equal 5. So that's 6 minus 1 equals 5. So the absolute value of 5 equals 5. So they're both are true. So there are two answers. Alright, so now when you mix absolute values with inequalities, it gets kind of crazy. So take a moment and show me what you think the absolute value of x less than 4 looks like on a number line. Or list all the possible values. So on a number line, here's 0, here's 4. So if you pick any number from 0 to 4, any of these numbers, it'll work. You can't pick 4 because there's no equality. But here's the thing, you can also pick negative numbers. So you can pick any number between negative 4 and 4. That is what you can pick here. Now, how do you actually solve this mathematically? Well, mathematically what you do is this. The absolute value of x is less than 4. There are two cases. The positive case, the negative case. Well, here this is just x less than 4. Here you divide both sides by negative and you get negative 4. You got to remember to flip the inequality. So what this says is you want every number less than 4. So graphically it looks like this. So you want x less than 4. And this says you want x greater than negative 4. So that looks like this. Now you've got to know this. This is called a conjunction. We use the word and for it. So if you look at the two graphs, the question is, where do they overlap? What do they have in common? Well, they have everything from negative 4 to 4 in common. So that gives me the graph I have above. Now, another way to talk about the values of x is we can say that negative 4 is less than x, which is less than 4. That is one statement. You can only write this inequality in that form. Okay, so now we're going to do this one. So the magic number is going to be 6, but it's also going to be negative 6. So you want the absolute value of x to be greater than 6, greater than or equal to. So you're going to have this graph, because any number out here would work, 6, 7, 8, 9. But also, if you take negative 6 and go to the left, any one out there would work. So this says x is less than negative 6, or x is greater than, or say less than or equal to, greater than or equal to 6. This is called a disjunction. And the word or is used. So when you solve it, the absolute value of x is greater than or equal to 6, you break it into two cases. The positive case or the negative case. Over here we use the word and, forgot to write that, because it has to be both. So here then we get negative x is greater than or equal to 6, which is x less than or equal to negative 6. Notice I divided both sides by negative and flipped the inequality. So there's where you get the two graphs. So here's this one, and here's this one. So you just combine the two into one graph. You combine them. That's what you're after. Okay. So when you're solving an absolute value, you want to try to isolate the absolute value and apply the definition of the absolute value and solve each case. You can never, well, not ever, never, ever, but things cannot come outside of the absolute value. You can't just add 5 to both sides. That's against the rules. You can't do that with an absolute value. You have to apply the definition. So I can start, though, by dividing both sides by 3. So the absolute value of 2x minus 5 is less than or equal to 3. Now I break it into 2 cases. So I have the positive case, and now n goes with the fact that it's less than or equal to, and the negative case. Now notice I'll put parentheses around the negative case to make sure I distribute that negative. So here we add 5 to both sides, so 2x is less than or equal to 8, divided by 2, x is less than or equal to 4. And now this is negative 2x plus 5 is less than or equal to 3. Subtract 5 from both sides. Negative 2x is less than or equal to negative 2. Divide by negative 2. Do not forget to flip the inequality. X is greater than or equal to 1. So I have 2 graphs. I have, right now you have this. You have 1 and 4 are the numbers, the critical numbers that are displayed here. You have x less than or equal to 4, solid dot, everything to the left. X greater than or equal to 1, solid dot, everything to the right. Your solution is where they overlap. So I want any number between 1 and 4. Okay, so now we're going to do the absolute, solve another one with greater than. So you got to remember that when you do greater than, it's or, but you got to make sure it's greater than when you solve it. So when you go to solve this problem, you want to get rid of anything on the outside that's like just in your way. So you start by subtracting 3 from both sides. So then you get the absolute value of 2x minus 5 is greater than 6. Now you're going to break this into 2 cases. The positive case or the negative case. For the positive case, we add 5 to both sides. 2x is greater than 11. Divide by 2. X is greater than 11 halves. Or distribute the negative. Negative 2x plus 5. Subtract 5. Negative 2x is greater than 1. Divide by negative 2. X. Now you're dividing by a negative, so you flip the inequality. So now on a graph, what you have is this. Here's 0, here's negative 1 half, 11 halves is down here. So x greater than 11 halves would be an open circle, everything to the right. X less than negative 1 half would be open circle, everything to the left. So remember, or means just to combine the two. You're not looking for what they have in common. You're just combining them. So you just drop them onto the graph. So it's any number less than negative 1 half, any number greater than 11 halves. And you can pick a number. 11 halves is 5.5, so like you can pick 6. Plug it into the original equation. So here we go. So I'm just going to test x equals 6. So that would be 3 plus the absolute value of 2 times 6 minus 5 is greater than 9. So I'm going to do some quick arithmetic. 2 times 6 is 12. 12 minus 5 is 7. So that's the absolute value of 7 is greater than 9. The absolute value of 7 is 7 plus 3 is 10. It works. So that's x equals 6. We could do x equals negative 1. Remember, negative 1 would be right here. So if I plug in negative 1, that would be 3 plus the absolute value of 2 times negative 1 minus 5 is greater than 9. 3 plus, let's see, that would be negative 2 times negative 1 is negative 2, minus 5 is negative 7, is greater than 9. The absolute value of negative 7 is 7, plus 3 is 10. You see, it works. But no number in between them would work. So if I tried to test 0, it's supposed to be false. See, both of these were true. That tells me they work. So if I try 0, 3 plus the absolute value of 2 times 0 is 0, minus 5 is greater than 9. 3 plus the absolute value of negative 5 is greater than 9. The absolute value of negative 5 is 5. 5 plus 3 is 8. 8 is greater than 9. Not this week. No way, Jose. All right? Okay. It says solve this equation. So here we go. So let's solve it. Positive is solve it and then come back to me. So I want to get rid of anything being on the outside of the absolute value before I begin. So I start by subtracting 2. So negative 1/2 times the absolute value of 3x minus 1 is less than negative 2. You do not flip the inequality because I'm subtracting. Now, I'm going to multiply both sides by negative 2. So this becomes the absolute value of 3x minus 1. I flip the inequality because I multiply both sides by negative 4. So it looks like this starts out is going to be an AND case because it's less than, but in reality, it's greater than, so it's going to be OR. So I set it up. The absolute value of 3x minus 1 is greater than 4, or the opposite of 3x minus 1, the negative case, is greater than 4. Add 1 to both sides. 3x is greater than 5. Divide by 3. X is greater than 5/3. Over here you get negative 3x plus 1 is greater than 4. Distributing the negatives. Subtract 1. Negative 3x is greater than 3. Divide by negative 3. And because I'm dividing by a negative, I flip the inequality. So x is less than negative 1. So x is either greater than 5/3 or less than negative 1. On a number line, it would look like this. So I have 5/3. I have negative 1. So x less than negative 1 would be this. X greater than 5/3 would be that. Alright, assignment 2. Make sure you work on this homework because I have no problem giving you a quiz. Where'd my little mouse go?